Welcome to Ask and Learn.
Let's use the ratio test to see if this converges. So we look at the limit n goes to infinity, an plus 1 over an, where an is given by this term over here. So first we have the numerator, an plus 1. So that'll be cosine, and then we have an n plus 1 here. And we're dividing that by the denominator here, n. And now we'll go ahead and flip this blue fraction and multiply it to the green. And when we do that, let's see here. So we'll have cosine n plus 1 over 3 over another cosine. And then n factorial, and then n plus 1 factorial. So let's simplify these separately. So here, notice that n plus 1 with a factorial, that can be written as, and so we'd go ahead and cancel those factorials there. And also, if you look at these terms right here, so cosine pi over 3, so for example, if an is 1, just write out a few terms of the sequence and you'll see it's periodic. We have a 1/2, negative 1/2, negative 1, negative 1/2, 1/2, and 1, and that would keep repeating. So that means that if we divide consecutive terms here, well, if you divide this divided by that, you get 1, an absolute value. This divided by that would be 2, an absolute value. And let's see here, we'd have, and that looks like the largest fraction that we would get. It'll be 2. So this is less than or equal to the limit n goes to infinity 2, and then we still have our n plus 1 from this term over here. So again, the absolute value is always going to be 1 or 2. And so we'll just use an upper bound and replace this with 2. That goes to 0 in the limit, which is less than 1. So we conclude by this that the series converges by the ratio test.